Yeah, you can do it by cubing, but it will become very, but see, that's not the point. Point is that even if you can do this for 2 terms or 3 terms, then you can generalize it. That's not the problem. So let's say that we have these 3 terms only for the moment. And let's say we want to show this. So C1 cube. C Yes, yes, yeah, right. It matters. Yeah, certainly. But it's better to know the basics better than, yeah, because usually you will not need a straightforward application, but nothing can be said. Yeah. So this one also, yeah, can be done by Cauchy Schwartz. So let's state the Cauchy Schwartz, okay? Because yeah, so the Cauchy Schwartz inequality in the first form it says, let's say 3 terms. It says that if you have this squares and then you have these squares, I mean, this has a very beautiful geometric meaning, okay? But just to state it, it is like this thing, and this thing is bigger than this thing is bigger than A1, B1, A3, B3. You understand? This is the Cauchy Schwartz. Okay. Yeah. This is the Cauchy Schwartz inequality, and instead of 3, this will also, you can also use it for n numbers. Okay, just the same thing. You have to. The proofs are a little difficult, so let's not do them now. Okay. Different. There are different, yeah, there are certainly different ways of representing it, but they are all, well, this is the basic way. Okay. So, but let us try to, let us take for 2 variables for a second and try to understand this. So, just, if you write it for 2 terms, you get this, and then you get this. Yeah. So you would have done some coordinate geometry. Okay. So we can try to see this geometrically. You can certainly prove this by multiplying and expanding and so on. And there are many, many ways. Let us say this is the situation. This is inequality, right? So it's saying that for any numbers A1, A2, B1, B2, they don't have to be positive. Okay. For any numbers A1, A2, and B1, B2, this is true. Okay. And you can put values in check. But how do you see this geometrically is the question. So to see this geometrically, let us see. This is so this is like this. This is so A1 comma A2 is going to be 1 point. Okay. So we are going to represent A1 comma A2 as a point. Okay, so this is our point P. Why are we doing it? Because can you tell me what this number here means? What this quantity here means geometrically? Yeah, but that, yeah, that's right. That only means the distance from that point P to the origin, right? right? That's just one point, right? So, and the other is always the origin. So you see, that's what this, so that's basically the length of this line, right? So OP, that is the length OP, is this thing. Now, similarly, you can make a OQ, and that is just the same thing. So far, it is simple. We can understand what these things mean geometrically. The left hand side. I mean, at least the two things on the left hand side. So let us see. 1 second. So here is b1 square plus b2 square. Now, in that case, what should be the in that case, how do you so if this is the angle theta, then what is cos theta? Can we find cos theta? Yeah. So we want to find cos theta in terms of the coordinates p, q, and o. Right? O is obviously we know, and p and q we also know. So in terms of those coordinates, can we find cos theta? Hmm. Yeah, but it's not right angle, right? So PQO is not right angle. Obviously, if it's right angle, then there's nothing to do, but it's not right angle. So then how do you do it? Have you studied the cosine rule? So you know the cosine rule? Okay. So then what does the cosine rule say? Cosine rule would tell you that cos theta is OP square plus OQ square, right? Minus, so what is that? 2, right? No, 2, or is it 2? Yeah, maybe 2. 2 into. No, that's right. But the cos theta we are already putting up. So you are saying in that way. That's also fine. So we can write that a square plus b square minus 2ab cos theta. But then what is cos theta, right? So cos theta will be this pq square by 2 times OP times OQ. You see, just multiplying and so on, right? So if theta is the angle, then you take the one side and you take the other side containing that angle, which enclose that angle. You square them and you subtract the opposite side and divide by OP. That's just the most natural form, natural way to write. Now can you use this? Now can you put in the values of OP and OQ that we already know? So let's put that. Let's see. If you put it, what do you get? OP square is A1 square plus A2 square, you agree? That's OP square. So what is OQ square? Okay, now you can also tell me what is PQ square. You know P and Q the points, so you can just use the distance. Yes, right? So if you do the expansion, yeah, that's exactly that, right? Like this, and then you have a2 square plus b2 square minus 2a1 b1, right? All these things. No, 2a1 a2. No, no, a1 b1, a1 b1, right? Sorry. And then we have 2a2 b2, which is just a simple things. And then if you obviously the denominator is also there, denominator is simple. This already you know. So we just keep putting the values of the not. I mean, this can be said much better in terms of dot products. But since we have not done that, we are doing it just purely simply geometry. And then you have this b1 square plus b2 square. Okay. Now, if you simplify, in the numerator, you can see that a lot of things are going to get cancelled, right? So finally, we will be left with a very curious expression, a1 b1 plus a2 b2. Right? That's a curious expression, right? a1 b1 a2 b2, which also appears in the inequality. Okay, okay. So that's the good thing. That's a good thing. Just one second. This is the old machine I'm using. And this is sending strange notifications. Oh, okay. Let's come back. So this is going to be this a1 square plus 2 square. So we are trying to understand the Cauchy Schwartz, right? What is it? What it really is trying to say. So yes, yeah. So the 2 is not needed. So right. So then we understand that this quantity has a geometric meaning, right? This quantity, this ratio that we have written in the end, this is cos theta. So you see, so it's not just a random, some algebraic expression, some meaningless expression. No, it has a meaning. It is saying the theta of that angle. Okay. So a cosine of that angle, theta. But what do we know about cosine in terms of inequalities? Like, what do we want to prove about this ratio? If we want to prove the Cauchy Schwartz inequality for 2 variables only, then what do we have to prove about this ratio? What do we want to say? This is bigger than something or less than something. Why? No. No, go to the initial inequality, this one, this thing, right? If you, yeah, well, what do we have to show there? In terms of the ratio, if you write it like this ratio, a1 b1 plus a2 b2 divided by that, this distance, square root of a1 square plus b1 a2 square and b1 square b2 square, And what does it become? Less than 1. That's what we want to show, right? This is the same thing. So this is the same thing as saying, right? So we are trying to prove it, right? We are trying to prove this inequality. We're trying to see this inequality of two variables. Then, right, then this quantity, I'm not writing the values, this quantity times this quantity, that basically means you want to show this is less than 1. You see, that's the same thing. And that is the quantity that we've got here in the end. Can we say it is less than 1? We want to say it is less than 1. Can we say that it's less than 1? It is equal to cos theta, some theta. So what do you know about cos theta? It is less than 1, right? Yeah, so that's okay, right? It is just less than 1, right? It's not even about the range. I mean, yeah, you can say it in terms of range, but it's basically the hypotenuse is bigger than the base. It is just the most basic fact, right? The hypotenuse is bigger than the base. So base by hypotenuse is going to be less than 1, right? You don't have to think about like, okay, it's a function or what is its range. You don't need all that, right? It's just cos theta is less than 1 because the base is less. And so because this is less than 1, we have established our claim, right? We have established that this ratio is less than 1. And that is what we wanted to show. Okay. So Cauchy's inequality is nothing but it's a geometric statement. Okay. When you take the Cauchy's inequality, you take the ratio, then this quantity you get is this quantity which you get, which Cauchy's inequality is claiming is less than 1. It is a very trivial fact because that thing is cos theta for that angle. So the meaning of this expression here is the cosine of the middle angle, right? And that has to be less than 1. You see? So it's the Cauchy's inequality is a very simple fact in that sense. Okay. And so in the same way, it is also true for 3 variables and 4 variables and so on. Okay. So we can just assume that for print. Now that we know it, we can try to think of this inequality. So let me just remove all this. So here, let's just try to first see this. So in that problem which was given, there were cubes, but let's at least do it for squares first. Okay. So we change it. We get that this thing is bigger than 3 times this. So let's see how we can apply the Cauchy's inequality to prove this thing. Yeah, right. So I think there will be a square here. Just one second. I think. Yeah, and also there will be a square here. Okay. So how do we do this? Wait, something was wrong. So in the problem, was it a square? Yeah, so in the problem, it was a square. So in our case, no, yeah, so that's, yes, but we are trying to do it for square first. Okay. Okay, right. So let's do that. And maybe the 3 will come. Okay, so can we prove this first? This is so you can try to understand that this is a simpler case of the problem, right? In the sense that there were cubes, I have made it squares, okay, and also just 3 terms. So This is 3 here. So let's see. I mean, first we should be able to do this, right? Then only we can think of doing that problem, right? So let's think. Try to think how you can do this. You can use the three variable version also. So this is this is the Cauchy Schwartz lever. 3 variables. This is the inequality. This times right. I mean, I can put a square root, but instead we can square it. And say we have proved it for 2 variables, but let's assume it is for 3 variables also. Okay, try to use this in this case. I mean, so you have to, you have to do some tricks, and you have to choose A1, A2, A3 wisely. This is true for, so focus on the inequality. Focus on the Cauchy Schwartz inequality that I've written on the right. Okay, yeah, right. Now this is true for all A1, A2, A3, and all B1, B2, B3. Okay. Now it is up to you to choose the A1, A2, choose the AIs and BIs carefully, so that it fits in your question. In this question about the C1, C2, C3. Now that you have to do. You have to choose them wisely. Okay. Try to compare these two and see what you get. Because it will never be a direct application of a formula. Right. So that is the inequality. Now you have to choose the things properly so it fits the inequality. don't square roots. You see, if you compare these two inequalities, what you need to prove and what you already have, right? You see, so this is what you already have, right? And this is what you need to prove. Then you need to choose the A1, A2, A3, and B1, B2, B3 so that you get this inequality somehow, right? Or somewhere close to it, right? You have to bring it close to that. So how do you get the 3 is the question. So you need to write the 3 as something square plus something square plus something square, right? It's on the left side. It's on the greater side. Yes, right? So you can write it like that. And then this is already in the right form. You don't have to do anything. This is your B1, B2, B3 square, B1 square, B2 square, and B3 square. You see, right? So this becomes your A1, right? This becomes your A2, and this becomes your A3. Just comparing it, right? And this is your B1, B2, B3. Now you apply Cauchy Schwartz, just the definition. What is A1, B1? It is C1. A2, B2 is C2. A3, B3 is C3, and then square. That's the inequality that's given to us. This inequality. So we are done. If we just choose the thing, so we have to write 3 as a sum of squares because that's the form in which Cauchy's inequality is given to you. Right. Because already you have square plus square plus square. So that fits with one bracket like this. But how do you fit this? How do you get this kind of thing? A1 square, A2 square. This 3 will provide you that. Right. If you break the 3 like that. And 1 square, 1 square, 1 square is the most obvious way to do it. Right. Okay. So now we can try to do this. Yeah. So now I think you can try to do that other one, which is cube. But I don't think you can do this with Cauchy Schwartz also. You may need to use Holder's inequality. I don't know in the book what exactly is the Cauchy Schwartz for them. They may be using some 3 cube version. So you try this for homework. Okay. Try and see what you get. See, in the worst case, try to expand it and see also. Okay. In the worst case, you can try that. And yeah, but I mean, as far as my understanding goes, this will be cube, right? This one? No. So that is, yeah, the original question. No. Next question. Yeah, so that was cubes here. These are cubes. Yeah. But that if you take for 3, see the n is not a problem, right? That is the same thing will work for n. Okay. That is not a problem. Just doing it for this cube is the question. How do you do it for cubes? You see, Cauchy's inequality doesn't have cubes. First thing. Right? Cauchy's inequality does not have cubes. Does it have? There are only squares. No, does it have cubes? The Cauchy's inequality. Does it have cubes? You tell me. Doesn't have cubes. But this question has cubes. Okay. So how do you do this using Cauchy Schwartz? So that is not too clear to me. Yeah, I don't know. That I don't know. Yeah. That is something which I don't know. I mean, this can be done in many ways. There is something called Shep-by-Shep inequality, Holder's inequality. So there is something called Holder's inequality, which is a version of Cauchy Schwartz for three terms. Okay, but it's pointless to discuss that now. It's a much more advanced inequality. Okay, so try it. I mean, I don't think it can be done only by Cauchy Schwartz. I mean, directly. Yeah, so I don't think that can be done directly. Okay. Yes, so you have to practice these simple questions, right? Like we did one simple question right now, right? So maybe you can. I'm giving you this. You can try this other question. This is another uh, application of Cauchy Schwartz. So this is x1 squared by a1, x2 squared by a2, and I want maybe you can take 3 terms. And you can do this in many ways, but Cauchy Schwartz is a good way to do this. Now you have to think this is more tricky. This you may have already seen, but you have to prove this. You have to get this from Cauchy Schwartz. Right. That is the challenge. The Cauchy Schwartz inequality. Yes, yeah, yeah. Yes, yes. So you can try this and you can also try other questions. So this is mm-hmm. Mm-hmm. Yes. So yeah, this is yes. I don't know. Let's see. So this is n times n to the power n plus I get a feeling that this will I don't know n factorial q. Let us think. So there is factorials in this, but I don't know if there is combinatorial. Hmm. Hmm. Yeah. How do you even do this? So one thing is correct that this you usually will not be needing Cauchy inequality and all that in this. Okay. And also since there are products on both the sides, I don't think that you will be using AMGM or anything like that. But might be wrong. Hmm. So n to the power n, and then we have if you if you take n plus 1 by 2 times n plus 1 by 2, okay, now this will be bigger than uh, k times n minus k. You can check this. So it's basically, you see, you look at the sum. If you look at the sum of the factors on the left side, it is n plus 1, right? And on this side, it is just n. Okay, so maybe then I should not do this. Maybe I should do, to make a better use of this, maybe I can do k minus 1 times n minus k, or k plus 1 times n minus k, right? You see, So the sum on both the sides is n plus 1 of the factors, right? Both is n plus 1, but the product maximizes when the factors are equal. Yeah, so you see, this is something that we had done earlier, right? If you have two numbers which are summing up to, let's say 10, then how do you split them to get maximum product? 5 and 5, right? Are they equal? They are. Yes, as close as possible. And n plus 1 by 2 is the closest possible, right? Okay, so yeah, so that is thing, you see. So if you use several of these, if you use this several times, yeah, so you use this like this. So you use it like this. We have n by 2, n plus 1 by 2, and we have another one here. This will be bigger than 2 times n minus 1. Just put k equal to 1, right? And then you can use it again. 3 times n minus 2. So you see, if you keep using this, then how many times? If you use it n times, then what do you get? You will get n plus 1 by 2 to the power n. And again, n plus, right? You just multiply all these on the left side, you get 2n, right? Because you're using it n times, and each time you're using it twice. Power is 2n. And what will you get in the factorial? You will get n factorial in this first column, right? You see 2, 3, 4, 5, it will be n factorial. Okay. And if you look at these, n minus 1, n minus 2, and so on, this will also give you, but this will not be n factorial, this will be n minus 1 factorial. Because it's starting with n minus 1, not starting with yeah. So that's a minor thing, not to be updated. So you see, you already have this. Okay. So if you already have, so what do you already have? You already have that. So you see, when I saw this 2n here, I got this idea of taking 2 at a time, using n plus 1 by 2, 2 at a time. Okay. And this is the kind of thing which we have done earlier also. When we showed that n by 2 to the power n is bigger than n factorial. You see, we had done this kind of pairing there, so pairing the bigger with the smaller. So this is based on that idea. And this is my emphasis, that you don't need to, one does not need to know a lot of advanced inequalities, but you have to be able to use this basic idea of pairing and so on. Let's see. So what have you already shown? You already shown that this to the power 2n is bigger than n factorial, almost like, I'm just writing a little here, a part of screen is not visible to me. It's a little kind of broke, damaged screen. It's n factorial times n factorial. Sorry, n factorial, I can just write n factorial by n. Right? Because that's n minus 1 factorial, is writing it as n factorial by n. So do you agree that till here we have shown this? Okay. Now it's not very difficult, right? Now, what do you want to show? Now your job is to show that this is bigger than n factorial times n, because that is the rest of the matter. You see, you had this n factorial cube which you want to show. You want to show it's bigger than n factorial cube. You've already taken care of n factorial square. Yeah, you see, so you've already shown that this part is strong. It's bigger than n factorial square divided by n. So then you want to show that the rest of the thing is bigger than n factorial times n. So that when you multiply, you will get the answer. Okay, and if you want to see this more directly, another way to see this will be that, okay, I have proved till here. Now let us see what I have to prove more. Well, I have proved till here. I can now multiply both sides. I'm just showing you an alternate way to see the same thing. And you will say, okay, now I don't know what to do, so let me just multiply both sides by n to the power n. Fine, we did it. So I multiply both sides by n to the power n. Okay. Now I want to show that this is bigger than n factorial q, right? That's the rest of the matter, right? So then what? Now you do the cancellations and all that you can do. You get that n to the power, you want to show this is bigger than n factorial. But this is very simple. You can try to show this. It's extremely obvious. Because on the right, on the left side, you're multiplying n minus 1 times, right? On the left side. On the right side, you have n, then you have n minus 1, then you have n minus 2. Right? So then till all the way to 2, right? That's the right side. The right side is n factorial, right? So it's n into n minus 1, then n minus 2, n minus 3. So you have this n minus 1 things which you're multiplying, but they're decreasing, okay? Starting from n. You see that, but the right side is not decreasing, so obviously it is bigger. It's a very obvious thing, right? Yeah. If we can just write it, okay, this is n, and now this is, there's no formula here. This is very obvious fact. This is n minus 1 times, but if you look at the right side, it is n minus 1, then n minus 2. So who's going to be bigger? Obviously, left side is bigger. This is just obvious. Anyone can say. So we are done. Okay. Yeah. So yeah, so that's it. So I will yeah, do this. So if yes. No. So those are some advanced things. Okay. But don't. Yes. Obviously, you can replace a1 with a power also. You can replace a1 with a1 square. It will change accordingly. Okay. Let me. Yes. So, yeah. So yeah. I'll discuss Cauchy. So you can. So I think don't do Cauchy's inequality now. Okay. Do the applications of simple applications of AMGM. Okay. So the simple applications like you will be there in your book, or if you just yeah, it will be there in some easy book like challenges and thrills and so on. Do the simple applications of AMGM. Try the geometry problems that I've given last class. So I will discuss them the next time. And yeah, do the simple things and just try the PRMO paper simple. Okay, because you see they will not have some advanced applications of AMG of Cauchy Schwartz and so on. Okay. Mm-hmm. Mm-hmm. Has a different power meaning? Mm-hmm. Yeah, we can try, but it's hard to make that work, I think. Yeah.